This is problem number 52, which uses Exhibit 2.1. In a story written in December 2002, the Des Moines Register reported on the average number of years of teaching experience for the elementary school in Des Moines, Iowa. The data by elementary school appears in the table below. In this video, I'm going to show you how to do questions 52, parts A through I, using the calculator and the theory discussed in this class. Question A asks us to construct a histogram, frequency distribution, and relative frequency distribution for the data using the class intervals 0 to less than 4, 4 to less than 8, and so on. So first thing we need to do is enter the data into the calculator's list 1, and then we'll go ahead and graph the histogram, and from the histogram we'll get the frequency distribution, and then we can start to build the relative frequency distribution after that. Okay, so let's go ahead and enter the data into the calculator. To open up the calculator's list environment, remember you just press the Stat button and then hit enter. If you already have data in this environment that you want to clear out, remember the way to do that is use your arrow keys. One way to do it is use your arrow keys, move your cursor to where it's highlighting L1, and then press clear, enter. Okay, so now we're ready to go ahead and enter the data in. Once you've got the data entered, we can go ahead and graph the histogram using the classes 0 to less than 4, 4 to less than 8, etc. To get that done, we're going to turn our stat plot on. So we're going to do this by pressing second y equals and hit enter. You want to make sure that your stat plot is turned on. So that means I need to highlight the word on and press enter. Now I can use my arrow key to move away from that. And I want to come over here and highlight the type of graph I want the calculator to do. It's a histogram. So move my cursor over to the histogram and then press enter. I want to make sure that my X list is actually the list where I do have the data. It's in list 1. So that's good. Now I'm going to go ahead and press the graph button. And if I press zoom 9, the graph will zoom into the histogram. Now this histogram, it's not exactly using the same classes that the question asks us to do. And the reason I can tell that is when I press on the trace command, it puts a cursor up here above the first histogram bar, and below that it tells me what the class limits are for this bar. This bar is going from 4.8 to less than 7.4, and on my histogram I want my first bar to go from 0 to less than 4 on the x-axis. So to change this to where it's correct, I'm going to adjust my window, my graphing calculator's graphing window. So press the window button. I want to set my x minimum to 0 here, the minimum value that I want my histogram to start at on the x-axis. I'm going to go ahead and set my maximum to maybe the maximum in the data set, or maybe something a little bit higher than that. When I look at the data, it looks like the maximum value is somewhere in here around 17.7 or so. So maybe I'll just go ahead and set my x max to 25. And I just want to be able to fit the histogram in the window. Now the x scale value here needs to be the width of each one of our bars, or the class width that we need for each bar. And if you take a look at the problem, we want our first bar to be between x equals 0 and less than 4. So we want the width to be about 4 units. So I'm going to make my x scale variable 4 here. Hit enter. And my y min, Y max, that should be okay. The Y scale here, I want to make that value the same value as the X scale. And maybe to make sure my entire graph is to scale, I'll go ahead and change my Y min to 0 and my Y max to 25. So this way I'll have a square window when I press the graph button. Both the X and Y axes will be to scale. So here's the picture of the histogram that I need to draw. I can tell that because my classes start at 0 to less than 4, 4 to less than 8, and I know that because when I press the trace button, it puts a cursor right here where the first histogram bar ought to go, and it tells me that the minimum X value in that bar is 0 and the maximum is 4. And also there's something over here, it says n equals 0, and that's to tell me that the first class on the frequency distribution has 0 entries in it. In other words, if you look at the data, there's no number in the data that is less than 4. So there's going to be 0 entries in that class, 0 to less than 4. The next class will be the class 4 to less than 8. If I just right arrow over, then my cursor moves over to the midpoint of the next bar on the histogram, and you can tell that that bar is between x equals 4 and less than 8, or it goes between 4 and 8, and there's 6 entries in the data that are between 4 and less than 8. So we can go ahead and start to make our frequency distribution and our histogram distribution table. So for that we're going to need a column that says classes, and we're going to need another column for frequencies, and another column for relative frequency or percentage. We'll go ahead and list our classes. We were told to go ahead and use classes 0 to less than 4. The next class will be 4 to less than 8. And then we're going to go 8 to less than 12, and so on. And how many classes are we going to need? Well, let's see how many histogram bars we had. 1, 2, 3, 4, 5, and then a sixth one for the class 0 to 4. So we need 6 classes here. Alrighty, so let's go ahead and get the frequencies. To do this, one easy way to do this is to get these numbers off the calculator. We know that the frequency, and we're going to do this just by pressing the trace button. When you press the trace button, then the calculator will put up a flashing cursor here right above the midpoint of the first bar. The first bar on the histogram goes with class 0 to less than 4, and it says that here because the min is 0 and the max is less than 4. And there are no entries in that bar, so it's a bar that has 0 height. In other words, the frequency of that class is 0. There are no data values that are less than 4. So the relative frequency of that class will be then 0 divided by the number of data entries, which of course is 40 data entries, and that's going to give us 0. Okay, the second class is associated with the second bar on the histogram. So to get over there, just press your right arrow key, and that moves the cursor to the top of the second bar there. And you can tell that this histogram bar, the minimum or the left edge of this bar is at 4, and the right edge of this bar is at x equals 8. So this is the bar associated with the class 4 to less than 8, and the frequency of this class is 6, because right here the calculator is telling us there are 6 entries in this class. So the frequency of that class is 6, which means the relative frequency is 6 divided by 40, which is 15%, or 0.15. Oops. Alrighty, so then moving on to the next class, I just need to press the right arrow again. That tells me, or that moves flashing cursor over to the third bar, which is between 8 and 12. The left edge of this bar is at 8, right edge is at 12. That's what the calculator is saying. And there is about 13 entries in this class, so that means the frequency of this class is 13. And the relative frequency is 13 divided by 40, which is about 32.5%. Moving to the next class, which is the class 12 to less than 16, there's a frequency of 9. And so the relative frequency will be 9 over 40. And that's, of course, a percent as a decimal. 22.5% as a decimal. To get to the next class, just use your right arrow key. There's a frequency of 11 in that class. We can double check that we're in the right class just by looking at the calculator screen. It tells us that this histogram bar, its left edge is on 16 and the right edge is on 20. The relative frequency of that class, 11/40. And then finally, the last class from 20 to 24, has a frequency of 1. Okay, so that relative frequency ought to be 1/40th, which is 2.5%. Okay, so that's how you can quickly get your histogram on the calculator, and then you can use your calculator's trace command to help you get the frequency distribution table from the calculator. So let's go ahead and take a look and see what the next question on the list is. Okay, so our next question is question B here. They want us to describe the distribution of the average number of years of teaching experience and note any unusual features. Well, when you look at the histogram, can you see that it's skewed, or can you see that it's symmetric? Well, talk to me about the shape of the data here. What shape jumps out to you? Is this shape skewed left? Is there a tail on the left, so it's skewed left? Is there a tail on the right, so it's skewed right? Or is it approximately symmetric, approximately normal? Well, if you take a look at it, it looks like it is approximately symmetric, and it doesn't appear to be any outliers. If anything, the data is slightly skewed towards higher values. So if anything, if there is any skew, then there would be a tail on the right and it would be skewed right. But there's not too much of a tail on the right forming, so it's approximately symmetric. When you go to question C, the question is, what is the 5-number summary for the data? Remember what the 5-number summary for a data set is. It's the minimum value in the data set. It's five numbers. The minimum value in the data set, quartile 1, quartile 2, or the median, the third quartile, and then the maximum value in the data. So to have the calculator give us that 5-number summary, we just have to calculate the one variable statistics for the data. And of course, you remember how to do that. You just come over here and press the Stat button. Right arrow over to the Calc drop-down menu. We're looking for the 1var stats command. It's command number 1 here. When I press enter, the calculator will give me this settings window here, or it'll paste the 1var stats command to the home screen. I have to tell the calculator I want the one variable statistics for list 1. So if L1 is not here, I'm going to press second 1, and then go ahead and leave your frequency list number blank, or you can make it 1 and then press calculate. So here I have the one variable statistics for the data. You can see the mean is 12.515. You can see the standard deviation for the population is about 4.2. And if I down arrow, press my down arrow 2 or 3 times here, then I get the 5-number summary, which is right here. So the 5-number summary is the following. The minimum is 4.8. The first quartile is 9.5. The median, or quartile 2, is 12.75. The third quartile is 16.55, and the maximum is 20.8. Okay, so now I can use those values to do part D, graph the modified box plot for the data. If I want to have the calculator graph the modified box plot for me first, one easy way to do this is to turn the stat plot on. So I'm going to press second Y equals, and I'm going to turn my stat plot 2 on. So I'm arrowing down to where I'm highlighting plot 2 and hit enter. And make sure to turn that plot on by selecting enter once your cursor is highlighting the word on. So now I'm going to arrow down until my cursor is highlighting the graph, this graph here, which is the graph of a modified box plot, which should show any outliers if there are any. And I want to make sure that my X list is the list where I've got the data. So now I'm ready to just press the graph button. Okay, and you can see I've got my histogram in the same window that I set, and above that is the box plot. So, and notice that there are no outliers on this box plot, because if there were any, they would be located with a point either to the left or to the right of these whiskers, and there are none. When I press the trace button and I arrow up, that'll put my cursor up here at the lowest point here on the box plot, which in this case is the minimum, and then of course quartile 1. If I arrow over, I'm at the median now. Quartile 3, I'm keep on arrowing over, I'm at the maximum. So the 5-number summary is used to make the modified box plot, but first you need to check for outliers, which of course there aren't any here, because if there were, the calculator would have shown us those outliers here. So there's no outliers, and the box plot ought to look like this. So we can quickly hand draw a box plot if we need to. Okay, so that brings us to the next question, which is E. Are there any outliers in the data? No, there's no outliers in the data, because if there were, we would see a point outside of the box and whisker plot. So one way for me to demonstrate that is, what I'm going to do is I'm going to go ahead and come back over in the data, and I'm going to go ahead and I'm going to enter in another point which isn't in the data set, but one that I think might be an outlier. Let's say let's see if 85 is a value that's probably an outlier. When I press the graph button, I don't see the graph of that outlier on the box plot, and that's because my window is only going from x equals 0 to 25. But if I press the graph button and then press zoom 9, you can see my box plot and the outlier over here. My window, once I press zoom 9, my window setting has been thrown off. So another way to show the outlier would be to just manually set the window. That's one thing you could do. The X scale sets your histogram bars, so that we wanted that set at 20. let's see here. So now I've got a square window. When I press the graph button, you can make out, let's see, you can make out the graph of the histogram, just barely, but you can see the box plot up here. And oh, something's going on here. What's going on here? My X scale number is 20, and I want my Y scale number to be 20 as well. Let's see, I don't want my X scale to be 20, I wanted it to be 4. That's what was going on there. Okay. So once I've got a square window, which I do because my X scale number and my Y scale number are the same, my X max and Y max are the same, okay, so now I'm ready to press graph, and you can see the histogram down there, the same one that we were working with before, and you can see the box plot there, and also you can see the outlier that I put in the data set, which is over here at 85. Okay, so if there were any outliers in the data, then you would be able to see those outliers outside of the box plot, and they would be graphed with a square or a dot as this outlier is. Okay, so there's clearly no outliers in the data because when we originally graphed this, we didn't have 85 in there. And there was no points outside of the box and whisker plot. So there are no outliers. So the next thing to do is question F, which is graphing the stem plot for the data. To get the stem plot graphed, if you have to do this by hand, something that would help with this process is to sort the data. So if we could sort the data in ascending fashion, we could quickly take a look at, or we could quickly make the stem plot. Let me show you how to sort. You should remember how to do it, but if you don't, let's just go ahead and go over that again. I'm going to open up my calculator's list environment by pressing Stat Enter. Okay, we've got the data in list 1, and what I want to do is I want to put that data into list 2 and then sort it. Okay, so I'm going to put the data in list 1 over in list 2. To get this done, I'm going to use my arrow keys to move my cursor towards highlighting L2, and then I'm going to press second 1 to set L2 equal to L1 and then hit enter. Okay, so now I want to sort the values of the data in L2, and the reason I'm using the second list is, well, I want to keep the original data entry in list 1 just so I can double check that I've even entered those numbers in correctly. Okay, so remember how to sort the data. It's pretty easy to just press the Stat button, and you can see that number 2 is the sort ascending command. So if I press the 2 button, the sort ascending command is pasted to the calculator's home screen. I want to tell the flashing cursor which list I want it to sort. I want it to sort list 2, so I'll press second 2, and the calculator puts L2 up there, and I hit enter, and the calculator tells me I'm done sorting the list. So open up the calculator's list environment and press Stat Enter to do that, and you can see, okay, the data in list 2 is all sorted in ascending fashion. Okay, so to make the stem plot, remember the rightmost digit of each number is the leaf, and then the digits to the left of the rightmost digits will form the stems. So I first need to determine how many stem rows I need. To get that done, I look at the minimum and maximum value. The minimum is 4.8, and the maximum was 20.8. Okay, so that tells me that my stem rows should go from 4 to 20. Okay, so I'll go ahead, and now I've got all my stems. Want to make another column here for my leaves. And don't forget to put we want to put a key in here that tells our reader what number type our stem plot is. So the key, well, I guess, would be looking something like this. For vertical line segment 8 means 4.8. Okay, so all of the leaves that are associated with 4, okay, we need to find those over here in the table. So actually there's only one number. The first number is 4.8. Its leaf is 8, so we'll go ahead and put the leaf next to the 4 there. The next number in the data, 5.6, has a leaf of 6, and then the next data has a leaf of 9. Okay, and then the next data value is 6.2, so its leaf is a 2. So 2 needs to go over here in the stem row that is labeled 6. Then that brings us to 7, or 7.0. The leaf on 7 is 0, and 7 happens twice, so we need to make sure there are 2 leaves of 0 next to the 7. Then the next data entry is 8.4, so the leaf is 4, which needs to go next to the stem row labeled 8. Alright, so just keep on going through the data here. Okay, the next value, 8.5, 8.6, those leaves are 5 and 6. So the 5 and 6 will be separated by commas and go in the leaf row titled 8, or the stem row rather, which is 8. Okay, so then the next data entry is 9.3. Leaf is a 3, and then 7, 7, 8, 9. Okay, so that takes care of all of these data values up to 9.9. 9.9 does repeat, so we need to have another 9 in the stem row labeled 9. Okay, so keep on adding leaves in there. The next data entry is 10.5. So, and its leaf is a 5, so 5 ought to go here next to the stem row labeled 10. Next data entry is 11.2. Whoops, I want to make sure all my leaves are lined up vertically. Okay, so then I've got 11.2, 11.4, 11.4 repeats, so I need to put another leaf in there of 4. Okay, and then we're going to 12.7, 12.8, 12.9. Alrighty, so then we're into 13. So it's a little tedious. The calculator just doesn't do it for us, so I guess that's a downside of the calculator. But you can see that if you have the data sorted, this process goes pretty fairly quickly. So right now I'm entering in the data value for 14. 14 has a leaf of 0, 14.0, so the leaf is 0. Need to make sure to have a 0 leaf in there for that. Don't just leave it blank. And then 14.9 occurs twice, so 2 leaves on the stem row labeled 14. And then 15.1, 16.2, whoops. Alrighty, so hopefully we're about done with this. 16.2, 16.5, 16.6, 16.8, and then 17 occurs twice, 17.0 occurs twice. So 2 zeros in the stem row labeled 17, and then a 2, and then a 5. Okay. So if you take this stem plot and you rotate it 90 degrees, you get a pretty good picture of what a histogram that has single numbers as classes would look like for this data set. So it's kind of exciting. The stem plot is a quick tool it's a quick graphing tool you can make, but also it's a quick tool that will help you visualize the data set, and also it shows every data value in the data set. So it's a pretty robust graph type. It's easy to make. Okay, so where did I pick up off on? 17.7 ought to be the next data entry. Okay, so then going into 18. Boy, this can be tedious, huh? And then 19.2. And finally 20.8. Okay, so that's your stem and leaf plot for the data. Don't forget to include a key in your stem plot. So let's go ahead and take a look at the next question. Where's that thing at? So the next question, we made the stem plot. The next question is question G. What is the percentile ranking for the data value 7.0 rather? And interpret the meaning of the percentile rank for 7.0. Okay, so remember what the formula is for percentile rank of a value. The percentile rank of a value x, that's equal to the number of data entries less than or equal to that value of x. And that needs to be divided by the total number of data entries, and then times 100%. Okay, so that means for our value of x, which is 7, we need to figure out how many data entries are less than or equal to 7. So to do this, I'm going to go through my sorted list here. I'm looking for 7 in my sorted list, okay. And it looks like 7 appears twice. And the second 7, you can tell down here, is the 6th number on the list. Okay, so that means there are 6 numbers less than or equal to 7 on the list. So the percentage ranking ought to be 6 divided by the total number of entries on the list, which of course there's 40 schools data, and then times 100%. That ought to give us 15%, or the 15th percentile. And the interpretation of this is the following. %, of schools have an average number of teaching years experience that is less than or equal to 7 years. Okay, so that's how you do that. Let's take a look at the next question. We've got the percentile ranking. We interpreted the meaning of that. And now question 8 asks us to find the z-score for the data value 7.0. And we're told to round the values of mean and standard deviation to the tenths before inputting those values into the z-score formula. We're also told to assume the data is a population. Okay, so to get that done, we probably need to recall our z-score formula, and also we need to get our mean and our standard deviation. So the z-score formula, remember what that is. The z-score of a data value x is x minus the mean, and then that difference is divided by the standard deviation. Okay, so we need to go get the mean and standard deviation for our data. Okay, so remember, to get that, you just run the one variable statistics command, press the stat button, right arrow over to the calc drop menu, hit enter, and we'll go ahead and run the one variable statistics for list 1. You can see up here at the top that the mean is 12.515, but we're being asked to round that to the tenths. So rounded to the tenths, mean is 12.5, and the standard deviation of the population rounded to the tenths is 4.2. Okay, so now we're ready to go ahead and find the z-score of 7 with the formula. That's just going to be 7.0 or 7 minus 12.5. Okay, and then we're going to take that difference and divide it by 4.2. So we'll go ahead and do that now. 7 over here, 7 minus 12.5. That'll give us a negative 5.5. We'll divide that by 4.2. And that'll give us negative 1.30. So I'm rounding the z-score to the hundredths. Whoops, negative 1.31. I'm rounding the z-score to the hundredths because that's what is commonly done with z-scores. They're commonly rounded to the hundredths. Okay, so that's how we found our z-score formula. Our z-score for 7. Is that a value of z that is unusual or very unusual? So in question I, is that z-score typical, usual, or unusual? Well, the z-score is typical since it's between -2 and 2.